The following is the video solution from JSDT Solutions. Question 8, 8.1 says, determine f prime of x from first principles if f of x is equal to 3x squared plus 2x. So, using first principles, we know that we need this f of x plus h. So let's get that first. So it's f of x plus h, meaning wherever you see x, replace it with x plus h. So this is 3, and there's x, so it's x plus h all squared plus 2, and again x plus h. Okay, let's simplify. So this is going to be 3 multiplied by, and we will square the first term, giving us x squared, square the last term, giving us positive h squared, and then first term times second term is xh, and then multiply by 2. So this is positive 2xh. Okay, and then we have, if we distribute in here, that is positive 2x plus 2h. Okay, and now we can also just FOIL in here as well. So this is 3x squared plus 6xh plus 3h squared plus 2x plus 2h. And that is f of x plus h. And now we can find f prime of x from first principles. So this is our formula. F prime of x is equal to the limit as h approaches 0, and it's f of x plus h minus f of x over h. Okay, so this is equal to the limit as h approaches 0, and f of x plus h is all of this that we just found. We've already expanded it. And we're going to subtract this by f of x. Now, you can choose to say minus and then put a bracket so that it applies to both terms, but we could also just see this as distributing it in. So if we're saying minus f of x, we're saying minus the 3x squared, so that's minus 3x squared, and minus the positive 2x, so that's minus positive 2x. Okay, it's going to multiply in there. When we say minus that, it distributes. Okay, and all of this will go over h. So this is equal to the limit as h approaches 0. And what will cancel here is whatever you were subtracting by. So 3x squared cancels with negative 3x, and then the 2x with the negative 2x. And then at this point, you can just take out your common factor. So the main problem is that h is in the denominator. So we can't find the limit at this point, because if we substitute 0, if we evaluate this, it's going to become undefined because your denominator is going to be 0. So what we're just going to do is take h out as a common factor, so it solves that problem. And now what are we left in this term when h is out? You're left with 6x. And in this term, we're left with positive 3h. In this term, we're left with positive 2. And this goes all over h. And then h cancels, and now we have, you can choose to substitute at this point, but I'm just going to write it for the last time. F prime of x is equal to the limit as h approaches 0, and we have 6x plus 3h plus 2. And now we can substitute. So it means that f prime of x is equal to 6x plus 3 times 0 plus 2, and therefore f prime of x is simply equal to 6x plus 2. And that is our answer. That is the gradient of this function at any point. Moving on to the next question. The next question says determine dy over dx. So we need to determine the derivative in respect to x of this function. Okay, let's just rewrite it first, just to analyze what's going on. We've got a square root of x. Okay, that's a problem. We have x under a radical, so we need to fix that. And then we have x under a radical, but it's also in the denominator. So minus 8 over the square root of x. And then plus pi x cubed. And this is fine. Pi is a number, so that's fine. Okay, so we can just say y is equal to, and we have 4. And with the x, we're going to rewrite this so that it has a base and a rational exponent. So the base is x, and the exponent is going to be the inside exponent, which is an invisible 1 on top of the x, and the outside exponent, which is a 2, because we have this root. This is a square root, okay? So it's going to be 1 over 2, and then minus 8, and now we have the square root of x. If you first rewrite that as x raised to the power of 1 over 2, and then you move it to the numerator, you'll see that the exponent will become negative. So it shouldn't be in the denominator. Okay, so we'll move it up to the numerator, and so it becomes negative 1 over 2 as the exponent. And then this is fine. There's nothing wrong with this. And now we can go ahead and derive. So dy over dx is equal to, and we're saying coefficient times exponent, which is 2, and then x, exponent minus 1, which will be negative a half. Coefficient times exponent, that's going to be positive 4. X, exponent minus 1, that will be negative 3 over 2. And then coefficient times exponent, that's going to be positive 3 pi. And then x, exponent minus 1, which is 2. Okay, pi is a number. So we're saying that number times 3 is 3.14 and then keeps going. It's still a number. Okay, and then at this point, you can leave your answer like this. You can choose to also rewrite these bases with positive exponents as well. Okay, moving on to the next question. Question 8.3 says, the graph of g of x is equal to ax squared plus b over x is equal to 96 has a minimum value at x equals 4. Okay, so from this question, you can already see that the way certain things have been named, okay, could be misinterpreted. And you would also notice that in the memo, they actually removed that question. So it's for 0 marks now. But we're still going to practice using this question. And this is how it works. So the graph of g has a minimum value at x equals 4. Do you notice how they say g of x and then they put down what g of x is equal to, and then they say is equal to 96. So that is actually the y value of this graph at this point where it has a minimum. So when we say a graph has a minimum, right, we're just saying, for example, if you have a parabola, this is the minimum value of this parabola, meaning we are pointing at the turning point. And we know what happens at the turning point. The gradient of this function is equal to 0. Okay, so they want us to calculate the values of a and b. Okay, so at this point, you'd probably notice that in order to find two missing variables, you need two pieces of information or two ways to form two equations. And they've actually given us this. So they told us that this graph has a minimum at x equals 4. So it means that we have this graph g of x, and at 4, right? And the y value that corresponds to this is 96. That there is a minimum at this point. So it means that we have the coordinates of x and y, and we also know that at the point where x is equal to 4, the gradient of this function is equal to 0. In other words, when we find g prime of x, and then you substitute 4, that gradient is equal to 0. So these are the two pieces of information we have. We have the information about the gradient of this function, and we have information about a point on this graph. And it is just enough to find the values of a and b. Let's go. So we can start by substituting this in place of x and y. So we're taking g of x being equal to ax squared plus b over x. And the x value is 4, so it's g of 4. And the y value is 96. So 96 equals a multiplied by 4 all squared plus b over 4. And if you simplify this further, you see that we can actually make b the subject here. We can make b the subject by multiplying both hand sides by 4, but let's just simplify first. This is 96 is equal to 4 squared is 16, 16a plus b over 4. And so to get b on its own, let's just multiply both hand sides of this equation by 4. Okay, so what is 96 times 4? It is 384. So this is 384 is equal to, and if we distribute, 16 times 4 is 64. So that's 64a plus b, okay, because the 4 will cancel. And now that b is without a denominator, we can leave it as b is equal to 384 minus 64a. Okay, and this is our first equation. Now to find the second equation, we'll use the information about the gradient. So to find the gradient of this function, we need to derive it. But currently it's not ready to be derived. So let's prepare it by taking that denominator of x to the numerator. So now we have g of x is equal to ax squared plus b. And then if we move it to the numerator, it will cause its invisible exponent of 1 to become negative. And now we have g prime of x is equal to coefficient times exponent is 2ax, and then exponent minus 1 is 1. Then coefficient times exponent is negative b, and we have x, exponent minus 1 is negative 2. And we're going to substitute the x value of 4 in here. So we're saying g prime of 4 equals 2a times 4 minus b times 4 raised to the power of negative 2. And we're specifically saying that g prime of 4, the gradient where x is equal to 4, is 0. So 0 is equal to, and 2 times 4 is 8, so this is 8a, and then minus b, and this is 4 raised to the power of negative 2, which you can rewrite as 4 squared, okay, moving it to the denominator, and then the exponent becomes positive. 4 squared is 16, so this is what we have, and now we can just make b the subject. So transpose it, it's b over 16 equals 8a, and multiply both hand sides by 16 to get b alone. So b is finally equal to 8 times 16, that is like 8 times 8 is 64, and then times 2. 64 times 2 is 128. So this is 128a, and this is equation 2. Okay, so we've got equation 1 and equation 2. They're both in terms of b. Don't even have to call it that. We can just say b is equal to b, and so 128a is equal to 384 minus 64a, and now we're just solving. So we can transpose that 64, 128a plus 64a is equal to 384. Okay, 128 plus 64, that is already a 12, that's 8, 92, 192. So 192a is equal to 384, and then we can divide both hand sides by 192. 192, and let's find out what a is. So 384 divided by 192 is 2. So a is simply equal to 2. And now with this, we can find b. So use the easier equation. You see b is equal to 128a. So we just say b equals 128 multiplied by 2. And so b is equal to 28 times 2, that is 56. So this is 256. And that is the value of a and b, and that is it for question 8.